Okay, this next video lesson will be on trig equations. I've drawn the unit circle. It's like it's coming back, all right, like a bad penny. It always turns up. Okay, so now we're going to solve trig equations, okay? Now, sometimes it might be easier that instead of using like sine of x, I'm going to use like x. I'm going to substitute like x for sine of x. So if I rewrite the equation, that's going to be 5x plus 2 equals x. And someone's like, Mr. Evans, that's really easy. I can solve that one. Okay, so I would like subtract 5x. Okay, so that's a 1. That's 2 equals negative 4x. Then divide by negative 4. Okay, so x equals negative 1/2. Okay, now at that point you've gotten back to the end. You've gotten your x equals. So go back and resub. Okay, your sign now. Okay, and so what I want to do is I want to do inverse sine and find where it is negative 1/2. Now we're doing this on the interval from 0 to 2 pi. So what I want to do is I want to look up and find where would sine, or O over H, be 1/2. And we've sort of done these already. Well, the O here would be this, okay? The H would be that. So I'm looking at the pi over 6 triangle. Now, as you notice, sine is negative. So I got to find the spots where sine is negative. Well, sine will be negative in this quadrant, and sine will be negative in this quadrant. So my answers here would be the ones with the 6's. 7 pi over 6 and 11 pi over 6. Boom, that easy, okay? So sometimes just substituting the x for the trig equation will make the problem easier, okay? Let's do another question, okay? So I got 2 tan x minus square root of 3 equals tan of x. So once again, I'm going to go ahead and sub out x for tan of x. So I got 2x minus the square root of 3 equals 1x, okay? So let's go ahead and solve here. I'm going to go ahead and subtract 1x. A lot of different ways to do the problem. So I got 1x minus the square root of 3 equals 0. Add the square root of 3, okay? So x equals the square root of 3, okay? At this point, I put the tangent back in. And I'm going to do inverse tangent of square root of 3. Well, what does that mean? I want to find where the O is square root of 3 and the A is 1, okay? Well, the O is square root of 3 and the A is 1 here, okay? So that would be the pi over 3 triangle. Now, this is positive, so, whoops, not pi over 6, pi over 3. Okay? All right? So this is the pi over 3 triangle. So I want to find where tangent is positive. Well, I already know pi over 3 is positive. The other quadrants here, that would be 4 pi over 3. Okay? And that's how easy those two problems are. Okay? Now, I got this one. Once again, I'm going to sub out x for sine of x. Okay? So this is going to be 4x squared plus 1 equals 4. So I would subtract 1. That's going to be 4x squared equals 3. Divide by 4. I got x squared equals 3/4. Take the square root of both sides. Now what's going to happen is that's going to separate to square root of 3 over square root of 4. That one reduces, so square root of 3 over 2. Okay? All right, once again, I'm going to bring back the sign. And I'm doing sine inverse. Okay, square root of 3 over 2. So I want to find where the O is square root of 3 and the H is 2. Okay? O is square root of 3, H is 2. That's the pi over 3 triangle. Okay? Now, since sine is positive, all right, we're good with that one. Now we just got to find the other one. Where else is sine positive? That quadrant. So I would use the 2 pi over 3. That's my answer. So, all right, this is basically a lot of the stuff that we've been doing, all right, in the past. Okay? Not a lot of complication here. Uh-oh, here we go. All right, so I got 2 functions. So, watch, let's make this easy. X is going to be cosine of x, and y is going to be sine of y, or sine of x. Okay, so watch. So I got x and y equals 3x. Okay? Now, the way you should solve this is subtract or move this back over, all right, using the opposite sign. So I got x, y, basically minus 3x equaling 0. Okay? So, to simplify this, what I would do is take out the x. So that'd be y minus 3 equals 0. Okay? All right, and now I'm solving them individually. I can solve x equals 0, y minus 3 equals 0. Okay? So I would add 3 here, y is 3, and this is just x is 0. So now I'm going to put these things back in. Okay? And I'm doing inverse for both of them. Sine inverse 3. Now, okay, for 0, okay, where is cosine 0? Cosine would be 0 at one of these axis points. So this is going to be the pi over 2, okay? So that would be pi over 2 for there. It's also going to be 0 down here at 3 pi over 2, okay? Now, got an issue with sine. If you look at my sine, it never gets a 3, and if I apply all of those, what sine would be, so this part, basically this part here is just not going to work. The only part that's actually going to work, all right, is that is the pi over 2, okay, is the pi over 2 and 3 pi over 2. The sine of inverse of 3, that does not work, okay? All right, and you can also test that in your calculator, actually. Sine inverse of 3 doesn't even get an answer, okay? All right, let's see, even if I do it, let's make it degree, okay? Tells me not possible, okay? All right, so that's how you can figure that out, all right? So what I'd like you to do, there are 4 problems that I would like you to try, okay? I'm going to just pause your video after each one, okay? In class, we'll do them as a group, okay? So I'm going to do tan of x is going to be equal to x. So I got 4x minus 7 equals 3x minus 6. Solve it like a regular equation. That's 1x minus 7 equals negative 6. Add 7. That's 1x equals 1, or x equals 1. Okay? Bring back the tangent. And I would do tan inverse. Okay. Now, when is tangent going to give us 1? Well, you might get fooled by the axis points, but those don't give us 1. Okay, which one, if I were to do O over A, would I get 1? That would be square root of 2 over square root of 2, so that's pi over 4. And since that's positive, that one's good. The other tan that's positive would be 5 pi over 4. Boom, those would be your 2 answers. Okay? All right, going on to this one. I'm going to go ahead and replace cosine of x with x. It makes it a little easier to solve. 7x equals 5x plus square root of 3. I would just subtract 5x here. So that's going to be x, or 2x equals square root of 3. Divide by 2. X equals square root of 3 over 2. Okay? Bring back cosine. All right, do inverse cosine. Okay? So where is the a square root of 3 and the o 2? Okay? A would be here, square root of 3. O would be 2, so that's going to be the pi over 6 triangle. Once again, this is positive, so I'm good there. Where else is cosine positive? Here. So I pick out the other, all right, example there that's 6. All right? Let's go to this one. I got cosecant. Once again, I'm going to take cosecant, all right, and I'm going to replace it with x. So this is going to be 3x squared plus 7 equals 11. Subtract 7. I got 4 equals 3x squared. Divide by 3. Okay, I got 4/3 equals x squared. Okay, take the square root of both sides. Okay, now that's going to be 2 over square root of 3. Okay, all right, with a plus and minus there. All right. I should have actually done that back. Where did I do this? Here. Oh, this should have been plus and minus the square root of 3 over 2. So this should be all of them. 4 pi over 3 and 7 pi, 5 pi over 3. Sorry. Forgot to cover that. Forgot that. Okay, so, all right. Got to be careful here with this. Okay, all right. So that's still, we can actually use that. We can get by with that actually. So I need to know where this is plus and minus. Okay. All right, of that, all right, if I put cosecant back in there, okay, all right, cosecant inverse, okay, of plus and minus 2 over the square root of 3. Now, so what that means is I need the h be in this and the o be in that, all right, so that's pretty easy. H is 2, o is square root of 3, so that's this one. Now, with the plus and minus, what that means is all work for that, okay? So that would be pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3, okay? All right, so it's actually easy to do that trig function there, okay? All right, ooh, multiple variables, okay? So I'm gonna do x, I'm gonna do sine of x, we'll substitute that for x. We'll do cosine of x, we'll go ahead and put that as a y. Okay, so I got negative 2x equals negative x and y, okay? So what I would do is I would add xy over to this side, okay? So I got xy minus 2x equals 0. All right, since they both have an x in common, I would take that out, so that'd be y minus 2, okay? So then I got x equaling 0, y minus 2 equaling 0. Well, that's easy, that's gonna be y equals 2, okay? So now I'm gonna bring back sine, all right? All right, so I wanna find sine inverse for when that's 0. Okay, when is sine 0? Sine is 0 at 0, and sine is 0 at pi. So I got 0 and pi. I bring back cosine inverse, or cosine of x, okay, of 2, and then I'm gonna do inverse cosine of 2. Now, if you ever get a doubt in that, just go ahead and put that into your calculator. That's error, so that's not even possible. So the only two answers there were 0 and pi, okay? All right, now, let's go into a couple more factoring ones, just so we can get used to those, okay? So what I would have here is I notice that I have sine squared in both, okay? So now you can do this. Let's go ahead and replace, all right? Sometimes this will work out for you, all right? So let's put sine of x is equaling x. All right, let's say a cosine of x is equaling y, okay? All right, so, all right, I got x squared, all right, y minus x squared equaling 1. If I take out the x squared, I would be left with y minus 1 equaling 1, okay? I set both of those equal to 1, okay? All right, so, actually that's not true. Let's make this a 0 instead, sorry. Let's make that a 0 instead. Okay. Sorry. All right, so I will bring back sine of x. So I take the square root of here, sorry. Take the square root plus and minus, take the square root plus and minus. That would just be x equals plus and minus 0. Okay, bring back sine. Okay, add 1 over here. Y equals 1, bring back cosine. Okay, so I would do inverse sine of when it's 0. Okay, when is that going to be the case? It's going to be the case at 0 and pi. Okay, and if I solve cosine of x, where's cosine of x going to be 1? That's also going to be 0, so I've already used that, so that's fine. Okay, all right, now, all right, I want to get this going. I got cosine of x, or cosecant of x, is equaling to x. So this is going to be x squared minus x plus 9 equals 11. So I want to factor this, so I want to subtract 11. So that's going to be x squared minus x minus 2 equals 0. So that's going to be x minus 2 and x plus 1 equaling 0. Okay, I'm going to set both of these equal to 0. Solve, okay? I would solve this, that would be x equals 2. I would subtract that, that'd be x equals negative 1. Okay, I want to bring back cosecant. So cosecant of x equaling 2. So inverse cosecant of 2 over 1. Okay, all right, and the same thing here. Cosecant of x equaling negative 1, doing cosecant inverse of negative 1. Okay, now, for the 2 over 1, we actually do have a situation where we have an h over an o, okay, that is 2. So h, okay, of 2, all right, of 2 over 1. So that would be pi over 6 for that first one. Now, since it's positive, where else is sign positive? That would be here. So 5 pi over 6 would also work there. All right, where is cosecant inverse at -1? Well, cosecant and sine are basically the same thing on the axis points. So that would be 3 pi over 2 for that answer. So those would be your answers for that one, okay? Go ahead and pause your video, okay? And go ahead and work on this problem first, okay? So I would replace sine of x with x. So I got 2x squared minus x minus 1 equals 0. If I factor that, just using some guess and check here, that's going, since it's negative, it's going to be -1 and +1. So quick FOIL, you figure that out, okay? So I got 2x plus 1 equaling 0. So I got 2x equals -1 divided by 2. I get x equals -1/2, okay? This one I would have x minus 1 equals 0. Add 1 there, I got x equals 1. Okay, bring back our sign. So sine of x equaling 1, inverse sine of 1. And this one, inverse sine of -1/2. Okay, O over H. Okay, so for the O over H of 1/2, okay, O over H would be pi over 6. Now, since sine is negative, I want to go where sine is negative. So that's going to be down in these two quadrants. So that I would have 7 pi over 6 for an answer and 11 pi over 6 because that's negative. Where is sine inverse 1? That's going to be right here at pi over 2. Okay? And I think this is the last question, I believe. Okay, I am going to change this to a 0. I don't think that that was set equal to 1. I think I made that one up. Okay, so I would do x equaling cosine of x, y equaling sine of x. So I got x squared and a y minus an x, okay, equaling a 0. I would take out an x. So I got x, shoot, that should be a, that should be a squared over here, sorry. Okay, all right, so I got, I should have taken out a cosine squared, I'm sorry, not a cosine squared, I should have x squared y minus x squared equaling 0. If I take out an x squared, I would have y minus 1 equaling 0, and I'd set them both equal to 0 to solve. This would be y equals 1, so I'd have sine of x equaling 1, inverse sine of 1. There's only one spot for that, and that's pi over 2. Okay, cosine x equaling 0, because I would take the square root of that plus or minus, just be 0. Inverse cosine, where is it 0? It is at pi over 2 and also at 3 pi over 2. Okay, so those would be answers. Sorry about a couple of those mistakes in that video. That's an intro to trig function. The next thing we're going to work in there are the identities of the trig function.